So the first thing I want to talk about is the basic problem of I know what I'm going to draw, and I want to make sure I draw them in the right order. Okay. So drawing order of primitives. And we're going to learn what's called the painter's algorithm, which sounds awesome, but it's really simple. Uh, it's so simple, in fact, that it's intuitive. I'm not sure it needs a word, but it has a name. Basically, the idea when you're painting a picture or painting a canvas is that objects in front include things behind. They include objects behind it. And sometimes partially, right? You can be partially visible. And I'll draw a picture. So you can imagine having your camera here. And then here's my view volume. And inside my view volume, I have a circle, a triangle, and a square like this. Now, because you know how the world works, you'd expect this circle to be in front. So we'd expect this to be rendered something like this. We have a circle, and I might be able to see the triangle poking out and the square poking out from behind it. But the circle should be in front. So that's what we want. But you can imagine that if you do it in the wrong order, you might get something like this, where you have your circle, but then you get your triangle here, and it's in front of the circle. And the square is in front of the circle. So this is a drawing order problem, and this is wrong. It's incorrect visibility. Okay, and so the basic approach to make sure we get the right one and not the wrong one is the painter's algorithm. Basically, we draw the furthest things first, then the nearer objects in order. Then the nearer objects in order. So it's just like painting on a canvas. So if I'm going to draw a scene, you can imagine first I'll draw my canvas, and I'll draw it black. I'll fill it with black paint, ink. You know, I'm going to have 3 examples, and I'll do them like that. Okay, and then what's going to happen is I want to draw a mountain, say. So I'm going to draw this, just draw this mountainous landscape, right? But because I'm drawing it on top of the canvas, I've covered up the black. The black is still there, but I've covered up the parts that I want, and I fill this with my green paint because I'm making a landscape. And then in the third scene, I'm going to want to draw a red feature like this. But of course, it's being painted on top of the mountain range that's already there, right? So it covers up the green that it needs to and leaves the other green behind, which is on top of the background. So the painter's algorithm, you draw the things that are furthest away first, and then the nearest objects later, and you get this natural layering approach. This ensures that the nearer things stay on top. So this is fantastic in 2D. In fact, if you did your computer science 1010 in processing, you'd be familiar with this. This is fantastic in 2D, but there are problems in 3D. Okay, there are definitely problems. One is we need to keep our objects sorted, which isn't hard, but it's not free. We have objects sorted from furthest to nearest, right? We have to have them sorted all the time. And if I'm in 3D, we need to do a resort whenever the camera moves, okay? Moves, rotates, all that stuff, then the scene will change. So we need to have a fast way to sort and query to get things in order. Now in 3D you might be thinking, well, I can figure that out, I can do sorting. But even then, Sorting is not always straightforward. There are problems here in 3D. Let me give you an example. So what, let's say, you know, hold on a second. So imagine the first question is what is depth if something's not parallel to the view plane? Let me show you what that means. So let's draw out a top-down view here. I have my eye, right? Here's my view plane. And I'm going to have these objects like this, and like these flat objects. Sorting is easy, back, front. Now, this is really ugly. Now, but what if the object is on an angle? Okay, it spans the z coordinates, so sorting is hard for that object. And we almost need to do it on the pixel level, okay? So when you have things that aren't parallel to the view plane, it gets tricky. We also have fail cases with overlapping. In 2D, you don't really get this. It's only in when we have a third dimension. So let me draw an example. Here's an object, and I want it filled, right? But then I'm going to draw another object that intertwines with it, okay? So it's going to go behind and come in front and stay in front, something like this. In fact, this should probably extend down. Okay. Right? So I have this object in front, like this. And this is going to fail with the painter's algorithm because which one do I draw first? If I draw the green first, the black's fully on top. If I draw the black first, the green is on top. So it fails. Okay? It fails, and you need to split the object up to make it work. And you might even be thinking, wait a second, Jim, you know, we just solve this by using triangles. Triangles can't go in and out of each other. Well, they can't if you have two of them, but let's see if I can draw a convincing example of where they can fail if you have three triangles. Green, let's use purple. That's supposed to be a triangle. Let's try making a triangle with three sides. And then I'm going to draw a blue. Okay. Now I'm going to tell you the depth that I want is this is green behind the blue, green in front like that. And then we'll have the fuchsia in front of the blue like that. And we'll have the blue behind the fuchsia and in front of the green like that. So in this case, painter's algorithm fails again. So the painter's algorithm fails. So we have these cases where it just plain doesn't work, okay? So in general, the naive, like just as we explained it here, I spelled naive wrong. The naive painter's algorithm is not really suitable for freeform 3D. It is fast and doesn't require much memory if you can keep things sorted. So it's not a complete throwaway, but if you're going to use it, you need to know what those limitations are and make sure you work within them. All right, let's stop here. I'll come back and we'll learn a different method, a different approach for solving this problem.